You have likely encountered this. You plot your keyframes, hit the spacebar, and the resulting movement looks stiff, robotic, and devoid of life. We can see the difference immediately. On the left, we have a basic, rigid motion. On the right, the ball carries weight and momentum as it travels across the screen. Stiff animation occurs when the movement on the timeline violates the physical laws of inertia and gravity that the human eye expects to see. To correct this, we are going to look at the specific workflows professional designers use to plot a primary horizontal travel path using position transforms. Plotting these technical setups with precision provides the inertia needed to transform a moving shape into believable motion. Start by opening After Effects, creating a new composition, and drawing a basic shape layer to act as your ball. A common error at this stage is leaving the layer's anchor point in the dead center of the shape. An anchor point in the center will cause issues during the squash and stretch phase. Instead of flattening against the floor, the ball will warp from its middle, ruining the illusion of a solid object hitting the ground. We need to use the Pan Behind tool, located here in the top toolbar. Press the Y key to activate the tool. Click the anchor point and drag it to the exact bottom center edge of your ball. By moving the anchor point to the bottom center, you define the object's true point of impact and its gravitational center for when it meets the floor. This adjustment creates the necessary pivot for every physics-based transformation applied later in the process. Select your shape layer and press P to reveal the position property in the timeline. If you set a keyframe right now, After Effects mathematically locks the X and Y coordinates together into united dimensions. United dimensions make it difficult to animate realistically because horizontal momentum and vertical gravity are two distinct physical forces that require different motion paths. To fix this, right-click the position property and select Separate Dimensions, splitting the data. The X track represents horizontal inertia, requiring a constant linear speed. The Y track is different, requiring curved Bezier interpolation handles to simulate the acceleration of vertical gravity. Separating these dimensions isolates conflicting forces, preventing the jagged robotic movements seen in amateur work. Now we will plot the horizontal momentum. Move your playhead to the beginning of the timeline at the 0-second mark. Drag the X position value until the ball is off screen to the left, then click the stopwatch to drop your first keyframe. Move the playhead forward in time. For this example, we will move to the 2-second mark. Adjust the X position value until the ball exits the screen on the right. This establishes your final horizontal keyframe. This creates a perfectly straight, dashed horizontal line across your composition. This is a motion path, which visually represents the trajectory the object will follow. Locking in these two keyframes establishes a consistent line of forward momentum before we introduce the complexities of vertical gravity. Play back your timeline now to check the initial movement. The ball should glide from the left edge of the screen to the right with a smooth, constant velocity. This independent horizontal trajectory ensures that the forward movement remains consistent, even when we add complex vertical bounces in the next step. Our next phase will focus on animating the Y position curves and applying scale transforms to create impactful contacts with the floor. Technical setups like these reduce the guesswork in your workflow, giving you a stable framework to refine your motion until it looks professional.